Okay, 7.3 is climate change mitigation and adaptation. So the idea of mitigating is trying to prevent reduce the cost of climate change, aka get rid of greenhouse gases. Adaptation is the idea of managing the impacts, adjusting our life to deal with the impacts of climate change. Mitigation, how to prevent, proactive, and adaptation is how we respond to climate change, which is reactive. So mitigating involves reducing and or stabilizing greenhouse gas emissions and then removing them from the atmosphere. So trying to reduce our emissions and also focusing on carbon sequestration, taking it out of the atmosphere, putting it into other places. So we could reduce energy consumption by making our systems more efficient, by making our vehicles more efficient, by traveling in different modes. We could mitigate by reducing emissions of methane from agriculture, by looking at, eating lower on the food chain is a great way to reduce your greenhouse gas emissions, for the fact that plants produce less methane, but also you get more direct energy from just consuming the plants. As you remember from the second law of thermodynamics, we lose 90% of energy each time we move up a trophic level. So eating at the bottom of the food chain is the most efficient. We could use alternatives to fossil fuels. So we could use things like hydropower and wind and solar, etc. But a lot of these renewable sources still do produce some carbon dioxide or other greenhouse gases, or also might have some environmental impacts in how they're produced. We could look at geoengineering. So we could try to reduce insolation from the sun by sort of creating clouds, or by creating like a giant mirror in space. We could try to capture and store CO2. There's ideas to fertilize the ocean by adding like nitrogen or phosphorus, and then having phytoplankton grow, which would then absorb CO2. And then other ways to increase reflectivity, putting white roofs on houses, or having solar panels over parking lots. Afforestation, those trees will create shade down there, and also will sort of keep things cooler than if you just have bare earth that's absorbing all the solar energy. So carbon dioxide removal include protecting and enhancing carbon sinks. So carbon sinks are just places that absorb carbon. So we can see carbon being absorbed through photosynthesis, and then the carbon ends up being stored in the tree and in the trunk and in the leaves, but also in the debris and detritus. And then there's also a lot of carbon in the soil itself, actually. So when we look at the agriculture unit, we'll look at how the soil system actually exchanges carbon. A look at carbon stored by different biomes around the world. And as you might guess, most of the forests happen to have a lot of carbon because most of that tissue is made from carbon-based materials. Another option is using biomass as a fuel source. So comparing them to fossil fuels, I mean, you still have like a lot of emissions that come from burning biomass. So it's generally not the best solution. Though you could say that biomass is significantly more renewable than other energies because it takes less time for it to regenerate. Biomass is a great example of like evaluating with positives, right? We do have a more renewable resource, but also negatives in that you might have to use tractors that are burning fossil fuels in order to grow the biomass in the first place. Burning that biomass also produces pollution. Burning that biomass also might create some particulate matter, etc. We have some examples of carbon capture and storage right here. Basically, sequestration techniques to take it out of the atmosphere and store it in places where it can't warm the climate. We could try to enhance carbon dioxide absorption by the oceans. Right now, the oceans are actually absorbing more carbon dioxide than we anticipated. which is nice because it doesn't affect the climate as much, but it's sort of less nice because then the oceans become more acidic as well. The real issue with this is even if we stop emitting greenhouse gases right now, there's still a lag effect. So all the greenhouse gases in the atmosphere today are still causing the climate to warm and are still having sort of a delayed sort of effect. Some adaptation strategies would be to reduce negative impacts and maybe even to sort of maximize positive impacts, right? So we're looking at like flood defenses and vaccination programs. Desalination plants could help get water from salty sources. We could start growing crops in areas that we wouldn't be able to grow crops before. You could look at how productivity might change, and you look at the Canadian Arctic and Siberia, and there might be a lot more productivity up in those areas. Some nice examples of mitigation, trying to reduce greenhouse gases, and then climate change, adapting to those changes, and how a lot of things actually can sort of meet both criteria, right? If we make our people more supported, more holistic, then it actually can address both issues. There's a lot of international efforts to deal with this, including the Intergovernmental Panel on Climate Change. This was done by the UN Environmental Program, which is why it's got all that sort of UN type of imaging to it. Oh, I guess that was a link or something. Whoops. Cool. So apparently you can click that link if you want. Some examples of skills and adaptations, including discussing different strategies for mitigating and adapting to climate change, evaluating the effectiveness of international climate change talks, and then some examples of international mindedness, as well as some TOK connections, and the shout out to MrKramerScience.com.